Let's return to our work from example 6. And example 6, last we talked about this, we had said that the area under this curve was 4 over n, this thing, 1 plus, kind of complicated, plus 3. And now our work is really cut out for us because we need to write this as a string of terms. And the first thing, so I've written this again, the first thing that you want to do is square what you can. So we need to square this thing. And once again, you know how to square a binomial by now. So we're going to have, I'm going to copy everything over. And my business right now is to square this. And I do know that when I square a binomial, I'm going to have the first term squared, plus I'm going to have twice the product. Well, that's easy because that's a 1. So that's going to give me 8k minus 1 over n is twice the product of these. And my last term is going to be the last term squared. So that's 16k minus 1 squared over n squared plus 3. I'm going to do a little bit more work because I have to square this. So we still have the limit as n approaches infinity. Sigma, k goes from 1 to n. We have 4 over n. Okay, and I'm going to try to write this as spread out as possible. I have 1. I'm going to write this as 8k minus 8. But since I have one term on the bottom, I can write that as 2 separate fractions. I'm going to write this as, I'll do this in 2 steps. I know we have k squared minus 2k plus 1 all over n squared plus 3, which is going to give us, very neatly so people can follow our work, 4 over n. So we have 1 plus 8k over n minus 8 over n plus, and I know when I distribute the 16, I'm going to write these as 3 separate fractions. 16k squared over n squared minus 32k over n squared plus 16 over n squared plus 3. In fact, I'm going to combine that plus 3 with the 1 in the beginning. And I'm going to distribute this 4 over n. So we have the limit as n approaches infinity. Sigma will have 16 over n plus 32 n squared k minus 32 over n squared plus 64 over n to the third k squared minus 32 times 4 is 128 n to the third k plus 64 over n to the third. Okay, all the hard work is done. Now, let's just use our sigma formulas. So we're going to have the limit as n approaches infinity. I'm going to apply these sigma formulas. So NA takes sigma, 16 over n. That's a constant, so I know that's going to be 16 over n times n. For my next term, I'm going to carry along the 32 over n squared. But sigma k is n plus 1 over 2. My next term is going to be 32 n squared times n. That's a constant. Next term, 64 n to the third, n plus 1, 2n plus 1, all over 6. I'm going to have minus 128 n to the third, n times n plus 1, all over 2. And then I'm going to have to put down here 64 n to the third times n. Okay, right away, here's what I know. If I take the limit as n approaches infinity, let me clean this up a little bit. So we're looking for the limit as n approaches infinity. The first term is just 16. The second term, I'm going to cancel out an n, cancel 2 into 32. So that will leave us with 16n over n plus 16 over n minus, this will give us 32 over n. Our next term is going to give us, this becomes 3, this becomes 2. Let's see, I'll have 2 times 2n squared plus 3n plus 1 all over 3n squared. Our next term is going to give us 64n over 2n squared plus, over n squared minus 64 over n squared, and then we'll have 64 over n squared again. But as n approaches infinity, here's what's going to happen. 16 is going to stay. In the next term, the n's cancel out. We're left with 16 again. But anything with just an n on the bottom, when the bottom outweighs the top, that's going to end up being equal to 0. So this goes away, this goes away, this goes away. As far as this term is concerned, what I know is that when I distribute this, this is going to give me 4n squared plus 6n plus 2 over each over 3n squared. So I know everything's going to go away except for the higher powers. And that will leave me with plus 4/3. So really I end up with 32 plus 4/3, which is 96 thirds plus 4/3, which is 100 thirds, as my exact area under that curve.